Several people have sent me emails asking for information about problem 2 on the written part, and so I'm going to give you a similar example but not solve that problem. The particular question asks for how to get the potential difference between points A and B on a circuit such as the one I've shown. I have a 5 microfarad capacitor here in series with the 10 and another 10 in series with the 5, and these two are in parallel with each other. So if I'm looking for the voltage difference between A and B, what I want to do is find out what's the voltage across the 10 and what's the voltage across the 5. So because we know that the bottom here, this bottom wire, is at the lowest possible potential in the circuit because it's connected to the negative end of the battery. So we'll call that 0 volts. So now if we have 30 volts in the circuit, and I have a 5 microfarad capacitor and a 10 microfarad capacitor, then those two in series, 1 over 10 plus 1 over 5 equals 1 over C. C is 3.3. Repeating. So the charge on those is C times V, which is 3.3 times 30 volts. So the charge on them is 99. Does that make sense? 3 1/3 times 30, 99, or roughly 100 microcoulombs, because these are microfarad capacitors. So then if I want the voltage across the 10, Q equals C times V, so V equals Q over C. Q is 100 microcoulombs. They each have that because they're in series, divided by 10 microfarads, so that means I have 10 volts. Similarly, I can find the voltage across the 5, and then I can use those to figure out the voltage at A. So for example, if the voltage across the 10 here is 10 volts, then if the bottom is at 0 volts, then this here over here in the blue is 10 volts higher than that, so point A must be at a voltage of 10 volts. So if you want to find the voltage at B, you can do the same thing and find the voltage across the 5 microfarad capacitor. That will help you find the voltage at B, and then you can figure out the voltage difference.